Okay, everybody, this is chapter 5, section 2. This is looking at trying to determine whether figures are going to be congruent, and that means are all the angles going to be the same and are all the sides going to be the same. Typically, we kind of just leave this to saying that triangles are congruent, but we kind of start off saying working with quadrilaterals, but really we're kind of working towards triangles. Starting with this section, going through the rest of this chapter. Okay, so make sure to, when you're watching this video, if you know get going too fast here, just hit pause, get your notes caught up, and then hit play and keep on going. Okay, on this particular section here, we're going to start off with highlighting this particular paragraph right here and this key concept right here. And then if we can go ahead and underline or highlight that particular sentence, okay? This is talking about congruent polygons. Polygons, a many-sided figure, which includes triangles. But we're looking at corresponding parts. So if you're looking at two figures, you're looking at this particular angle and another angle that should be the same on the other figure, whatever that might be. So those are corresponding. We also look at corresponding sides. So looking at, let's say, a triangle, you're looking at one particular side of one triangle, and you're trying to consider, can it be congruent to the corresponding side of another triangle? If they are, then we could say that the triangles or the figures are congruent, but since we're kind of working with triangles, this one term down here, CPCTC, is kind of a term we'll be playing with a lot. And it's just saying if congruent parts of congruent triangles are congruent, then the triangles are congruent. And we'll kind of play some games with that as we go. Okay. All right. If we come down here, look at this first example. They kind of did it for us, but we've got these two trapezoids, and they're saying that they're congruent, or they want us to determine if they are. And if they are, then we have to write something called a congruence statement or a congruency statement. Okay, and this is kind of the example that we need to do. So if you could highlight that particular piece, if they are congruent, if we've done our rules and we've been able to do some things or say some things, I can say that all the angles are equal and they're corresponding. So an example is that if you look at angle A and W, they're in the same place in both trapezoids. Okay, so we could say those are corresponding. So I have to write them that way. I can't say like angle A is equal to angle Y, because it's not. So I have to make sure I match that up. Same kind of issue here with the sides too. If you look at this example, CD is the same side as YZ, and we kind of kept the order. C was on top, went down to D. If you rotate that second trapezoid, Y is on top, and you draw it down to Z. So we just got to make sure we're keeping the term corresponding in mind when we write this. After I've written all that, so I've proven all the angles are equal, I've written all the sides are equal, I can then come down and say that this, in this case, trapezoid ABCD is congruent to trapezoid WXYZ. Okay, so you have to write a congruency statement if you want to write this down. To write the proper congruency statement, you take the number of sides of the figures. Okay, so there's this a four-sided figure, multiply it by 2, and then add 1. So it was 4 angles, 4 sides, okay, and then you had the figures, the two trapezoids together, okay. So that gave me 9 pieces here, 4 angles, 4 sides, and the figures, 9 different pieces to make that up. So if I had a triangle, it would be 3 sides multiplied by 2, and then add 1. That's all the number of pieces I have to write. Okay. If you take a look at this particular one down here, they just want you to practice this. So once again, I have a four-sided figure. It's not really a trapezoid, it's just a quadrilateral, but I got to match up sides. So angle P should be equal to angle G. Angle Q should be equal to angle F. Angle R should be equal to angle E. And angle S is equal to angle D. So remember, when you're looking at angles being equal, it's the number of arcs match up. Those are corresponding, okay? And then if we look at PQ, that should be GF, side GF. If you look at QR, that should be FE, side FE. And RS should be ED. And then SP should be, I think I have to go on this one, make sure I'm saying this right. SP should be to DG. Okay, had to make sure that I put it in the same order. Okay, so pretty easy. I hope you're okay with that. Then I can say that, you know, this quadrilateral, and I'll go kind of alphabetically, PQRS is going to be congruent to GFED. Okay. So that's a congruency statement. It was a four-sided figure, so I had 9 pieces that I had to write that were going to be congruent. There's your example. Okay. All right, shouldn't be too hard. You know, just a lot of common sense kind of for you to be able to do that. If you're taking a look at this one, we have to solve here for X, and we got to get it for Y, but I want to make sure that we highlight this up here at the top, that triangle RSB is congruent to triangle TBS. And we got this reflection thing going on right here, so we got to be a little bit careful. I could tell that angle R is going to be congruent to angle T, mostly because they did tell me up here that the triangles are already equal, so I don't have to prove anything. I just got to use that to solve for stuff. Okay, so R and T should be the same. They're angles. All right. Now, what I need you to make sure we understand is, like, you're talking about angle S and angle B, but which angles are we talking about? And we got to remember that VT is, if you look at the, you know, the statement up here, VT and RS are the same. So if this is 90 degrees here, then this is going to have to be 90 degrees over there. If this is 78 right here, then this should be 78 right there. Okay. So taking your triangle sum principle to get X, or angle T, you know, T and this angle 78 should add up to 90, since this is 90. So if I go 90 minus 78, I should get 12 degrees for angle T, or X. Okay. If I'm taking this, I got to match up RS, going back to the congruency statement up here. RS is equal to TV. So I want to take that 2y minus 1, set it equal to 24. Okay, and solve it for y. So I'm going to add 1 and get 25, and I'm going to divide by 2, and I get 12.5 for y. Okay. All right. So this is the work here. This was going to be 12 right here, and we got, you know, y is equal to 12.5 down there. Okay. When we're looking at this congruency statement, they're kind of going back to what I was showing you before. We got to match up the pieces. So remember, I underlined RS had to be equal to TV. So when you're doing these problems, you just got to make sure that you go back and kind of look and make sure you see what's going to be corresponding here. Okay. All right, that's good there. Okay, in this particular diagram, once again, I'm going to go back and I'm going to take a look at. They tell me that these two triangles are congruent, so I can say that all the corresponding pieces are equal. What I need to make sure we understand, I do this when we get to these problems. This figure right here they're giving me looks like an hourglass. Okay. And we can also take this figure and kind of dump it on its side, and that, to me, that's called a bow tie. Okay. In both of these particular types of questions, you're always going to get these angles right here, and those are always going to be vertical angles. So they should be congruent to each other. Okay. So you're going to use it a lot in proofs, but you'll use it a lot in just solving for, you know, the angles and helping you be able to do some of that work in a question like this. So if they are equal and I gotta find y, I'm gonna come down and look at this right here. That's a 90 degree and a 38 degree. So this 38 degree and this angle right here should equal 90 degrees. That's the easiest way for me to get y, because then I can use the vertical angle rule. So to get, you know, sometimes I got to go get an answer to get something else. So I'm going to take 90 minus 38, and that's going to get me 52 degrees. So that's this angle right here, but it's vertical with y, so y should equal 52 degrees also. Okay. To solve for x, I can just take, hey, I know that AB and DE are going to be congruent, because if I go back up here, AB and ED are corresponding. So I could take that 3x minus 10 and see, set it equal to 20 and just solve that for x, okay? So I think kind of common sense there, but just taking the rule here of, you know, corresponding sides, you got to set them equal and solve it. We've been doing that a lot this year. So hopefully that makes sense, okay? The other thing too, though, I just wanted you guys to get this. Every time I have that, I get vertical angles, and we just need to keep that in our head, okay? All right. Okay, in this particular one, we have this new theorem. It's called the third angles theorem. So if you could highlight this, please. All right, highlight that. Highlight the picture too. Now, this should be, once we talk about it, this should be kind of common sense. If I have this triangle ABC and I can determine, or they tell me, hey, you got these two angles and they're equal to these other corresponding angles over here in the second triangle. Well, we remember that a triangle always equals 180 degrees. And if two of them from one triangle are equal to two of them to another triangle, shouldn't the third angles have to be the same, still have to equal 180? So I should be able to say then that angle A is equal to angle L. Okay. Now, just kind of side note though, just because the angles are equal doesn't mean the triangles are going to be equal. I can still draw two different triangles with the same angle measures, but with different side lengths. So don't get caught up in that, but the rule here is if I got two that are equal to two others in another triangle, the third angles have to be equal, whatever they might be. Okay. Down here below that, if you'll highlight these other rules that we've kind of talked about, but we've talked about them in other chapters, but we're bringing them back here for triangles, this reflexive property. So can a triangle be equal to itself? Yes, it can. If I have two triangles and I say they're congruent, can I change the order and still keep it congruent? Yes, you can. And we've got, you know, our old friend, the transitive property, you know, and I had, in what I would do here when we have that, I got triangle A and triangle B, then I got triangle B and triangle C. So remember, can triangle A be equal to triangle C? Sorry, get rid of that. Okay, so you heard this before. That must mean I need to know this particular rule because I'm going to see it again and again and again. I better remember it. Okay. Go here to this particular triangle. We're taking that third angles theorem, kind of illustrating it. Okay. If I take what they tell me, angle ABD, which is down here. Okay. and I get is congruent to triangle CVD, which is this angle, all right? And they're showing me up here at the top that I got two angles that are equal to each other. Well, I've got one angle here and one angle here are equal to the same corresponding angles here. Shouldn't then angle A be equal to angle C? And that's using the third angles rule, okay? So in this case, they want me to find what is angle CBD, okay? Well, they gave me some information here. Angle BAD is 58 degrees. So if that's 58, then this should be 58, okay, by that third angles rule. And then that will let me get this angle down here, okay? So if this is 90, then these other two angles have to equal 90. So I should be able to take that 58 degrees and subtract it from 90, and I get that that angle's 32 degrees, okay? So that's just taking that new rule, knowing that a triangle equals 180, knowing that if I have an angle that's right, that the other two have to be equal to 90 together. I used all that there to help us get that one. Okay. So that was just the work they did for you there. I try to do with the picture because it's hard to do that without it. Okay, we got this, the kite, okay? They're telling me angle BAD is congruent to angle BCD. Okay, so that's these guys down here, and they tell me that they're 45 degrees, okay? Now, if you look down here, if you got that one angle's 90, then that means this has to be 90 because they're a linear pair, they're supplementary. So that means that if I'm trying to find the angles up here, which they're asking me to get one of them, they should be complementary. So like this angle here and this angle here should add up to 90. Well, if I go 90 minus 45, I'm going to get 45 degrees. So if this guy's 45, then this one has to be 45. So I get you the angle that they're asking you to find. Okay. Okay. Just a really quick proof here they did for you. They want you to prove that the two triangles are congruent down here. They give you a bunch of stuff, and then they give you how to be able to do the proof. So a big thing here is when you see the word bisect, you have to define what gets bisect. L bisects KM, so that means that this has to be equal to this. Okay, but we have to state it, so that's what they're doing right here. Okay. The other thing that we don't see here too is that these are vertical angles right here. Okay, so this is a bow tie kind of situation. So I have to be able to state that those two angles are equal. And I had to use 3 letters because, you know, what angle L are you talking about? There's like 4 of them right there. So I have to give you the angles that are inside the triangles, which they did right here. So I have to state which angles are equal, okay? If they already told me that J and P were equal, and I just said that these vertical angles are equal, then angle K and angle M have to be equal by that third angles theorem that we just learned a little bit ago, okay? So that's why I could say step 4. All right, and then now I've got all the angles are equal, I've proven all the sides are equal, I can now say that the triangles are equal by just the definition of congruent triangles, because everything was equal in those, okay? So that's a big one right there. I'd start and highlight this example right here. That would be something that you'd have to do. We're going to get back into what does bisecting mean. Cuts it in 2 equal halves. We have to know what vertical angles are, okay? And you're going to use that all the time. So it's just really, if you know your stuff, proofs are equal or pretty easy. You just got to make sure that you can state things are equal, like the segment bisector and then the vertical angles thing, you have to state what's now equal when you're given that situation. Okay. Okay. In this particular one, they want you to write a paragraph proof. They gave me a whole bunch of stuff, and I just have to fill in 2 boxes, so we'll do this really quick. But when you got a picture like this and they give you all this given stuff, write it down, show it on your picture so you know what you got. WXZ, which is this angle, is equal to angle YXZ, which is this angle. Okay. XZW down here. Now, they're not telling me it's right, so I'm just going to say they're equal to each other, but I'm going to need to assume that they're right for them to be equal down there. Okay, and then they're telling me that WX is equal to YX and WZ is equal to YZ. So take everything they give you and prove it. Okay, so I got to prove that all the corresponding pieces are equal. Well, in this case, if I can say that the XZ right here is equal to XZ to itself, so that's the reflexive property. So something's equal to itself. So this piece right here is part of both triangles, so I can say that they're equal. Okay. I then have to be able to prove that this angle and this angle are equal. Okay, so I can prove them by that third angles theorem. And now that allows me to prove that all the angles and all the sides are equal to each other, so I can say the triangles are equal. Okay, so you're going to get that a ton. And this reflexive thing that we just did here, the third angles thing was the last step, and we used the other proof a second ago. It's just stuff, if you know that, it's easy to do a proof. Just got to know your rules. Okay. All right. Okay, and I think that takes us to the end. So, hey, let's do a really good job on this. There are a lot of proofs now, but let's not be scared of that. Let's use the rules, so study, know them, and they'll, really make it easy for you to be able to do them. Okay, and don't worry about what goes next and what has to go first. Sometimes when you have to do the whole proof, order's not really going to matter. You just need to tell me what you know in the picture. Okay. All right. Thanks.